I wanted to structure these courses a little different to what you might be used to if you've tried to do a software development course before. I find a lot of the methods out there to be quite boring and long-winded and often don't achieve the result that you want anyway. I want to teach you how to make high-quality, scalable games. And I want to teach you how to make them quickly. I don't want to faff about for ages about stuff that you won't actually use. Game development is meant to be fun, and I sure hope I can make that process fun for you. These lessons will start by a very visual explanation of the feature I'm looking to teach you. These videos are focused on showing you where the technology fits into the big picture and how it works conceptually, with a little taste of the code as well. Each of these videos will have a part A, which is the practical demonstration. This is where you get to put theory into practice and follow along making your application. My hope that structuring the course this way will help you commit it to your long-term memory and also be able to understand the code as you're writing it. As mentioned earlier, the SpriteKit framework is designed to help you create 2D games. This framework is near identical for both iOS and Mac. So what you'll be learning will be relevant no matter which platform you decide to use, or even both. If you have never heard of a sprite before, it refers to a static or animated two-dimensional image. The sprite object can be as simple as a static photo frame on the wall, or a full-featured character with movement states and physics. We are going to talk about sprites a lot, but first, we need to address how everything ends up on the screen and how it can be controlled. There are two classes in play here. There is the view, which defines the visible area of the screen where your game can be displayed. Directly inside your view sits a scene. The view generally remains static for the entire duration of the game. However, you may change the scene many times. Let's say, for example, you're playing a game which is based around a set number of lives, and you fall down a hole and die. The game could then transition you to a post screen. It may then transition you back to a main menu, where you can choose to play another game, which would then transition you back to the game scene. In summary, a scene is a node that can contain and display nodes. The key word there, and also the most important part of SpriteKit, is the concept of nodes. So let's talk about nodes. The scene, any sprites, labels, shapes, particle effects, etc. are all subclasses of a class called skNode. In Swift, you can think of classes as blueprints. With one blueprint for a house, you can build many houses. A subclass would be if you took the same blueprint and added a second floor or a pool to the house. It's building on top of the existing blueprint. You can think of skNode as a very basic blueprint. Maybe it's just the foundations for the house. It can't really do too much on its own, but by existing it helps with all other blueprints. So the master blueprint for all other SpriteKit classes is skNode. So what does an object built from an skNode look like when it is added to a view? Nothing at all. It is quite invisible on its own, but it is definitely there. The skNode has a few properties that are very important as a foundation for all other objects. You'll be looking at these in the skNode video, but for now let's focus on the property called position. To understand position, think of your view as a Cartesian plane, with x and y values representing horizontal and vertical positions respectively. The scene is added at position 0, 0, which is at the bottom left corner of the view. Each point represents 1 pixel, or 2 pixels on a retina device. So if you added a skNode to the scene at position 50, 20, then it would look something like this. Nodes aren't just added to scenes, they can also be added to other nodes. This is useful when you want to move nodes together, such as a man with headphones. If the man has the headphones as a child node, then they will move together. A more common example in game development might be a health bar always appearing above a player. How does this work? It's called a node hierarchy. Each node has one parent. Each node may also have a child node or many child nodes. This may be a lot to take in for your first exposure to SpriteKit, but the sooner you understand how it is structured and how nodes work, the sooner you will be able to take control of SpriteKit and use it better than most other beginners. Now let's have a look at what this looks like in actual Swift code.